Good morning, students. Today we are going to see about lens. Okay. Already you have studied in lens in 9th standard about the types of lenses, that is concave lens and convex lens and different types of lens. Okay. Now, what is lens? Lens is nothing but it is a optical instrument or optical medium. It is a transparent material. When we pass a light through that material, it may be refract. Okay, it may be refract through the lens. So that is nothing but lens. For example, I will show you the two types of lenses. That is, one is concave lens and another one is convex lens. Concave lens is, otherwise I can say it is a biconcave. And a convex lens, or otherwise it is called a biconvex lens, because it has different types of lenses. Okay, now I will show you. So this is the one type of lens. It is a transparent medium, okay, which can reflect the light. When the light passes through this lens, it may be reflected and it comes through the lens. Okay, say when we are seeing this lens, there is a different shape and size, we can say. If you take a convex lens, at the center it is a thicker one. Okay, the center point of the lens, it is a thicker, and at the edge of the lens it is thinner. Okay, the total length of the surface of the lens is thinner at the edge, but at the same time at the middle, at the center point, it is thicker. Okay, the shape, from this shape we can find it is a convex lens. Okay, it is a convex lens due to the reason of thicker at the middle, thinner at the edge. Okay, now next one we will see the concave lens. Okay, this is a concave lens. So it is shape and size, you can see the function, that is nothing but thinner at the middle. Okay, see here, thinner, very thin at the middle. At the edges it is very thicker. Okay, the thicker at the edge, thinner at the middle. So this shows, we can identify easily, this is a concave lens. Okay, so when the light passes through this, what will happen? It will refract. Okay, so what is the function of the lens? When the light passes through a lens, it may be diverged. Okay, so it is called diverging lens. Okay, what is that? It is called a diverging lens. When the light passes through the lens from different place, okay, when pass through this, it may refract and it may be deviate. Okay, or otherwise you can say it is a divert. So it is called a diverging lens. Okay, the same way for convex lens, when the light rays pass through the convex lens, or we can say number of rays falls on it, all the rays will be converged at the other end of the lens. Okay, so whatever it may be, for example, if you take sun or other any light source from long distance, that will come in a number of rays as a parallel beam or parallel rays and falls on the lens, convex lens, and it will be converged at one point. It will be converged at one point. So while the rays which is converging at one point, that is nothing but focal length of the lens, focus, or otherwise you can say focal length of the lens. So when the focal point, if you use cotton or paper, it may be burned. Okay, for example, when sunlight passes through the convex lens, So all the rays are converging at one point. At the converging point, if you keep any paper or cotton or anything, it may be easily burned. Okay. So this is the function of the convex lens and the concave lens. Okay. So there are two types of lens. One is convex lens and another one is concave lens. Okay. Now we will see different types of lens and the different function of the different lenses. Okay. So first one we will see diverging lens, which I told you. Is it? So diverging means the rays when falls on the concave lens, it may be deviate and it may be divert. So it doesn't converge. Okay. So that is called what is that? Diverging. Now we will see converging lens. Okay. Converging lens and the diverging lens. Here converging lens. Okay. For example, it is a small or lens, you can say, when the rays, beam of rays comes from a distance. See, while you are drawing this diagram, you have to draw the arrow mark. Why? What is the reason? In which direction the light rays is coming and falls on the lens. Okay. So for that purpose, we have to draw the arrow mark. So that arrow mark denotes that direction. So when the beam of rays or the parallel rays falls on the lens, and it may be converged at one point. Converged at one point. Okay. So this is nothing but the focal length of the lens. Okay. This is nothing but the focal length f. So here, if you keep this any paper or cotton, it may be burned. I already told you. Okay. So in this converging type of lens, first one is concave lens. See, in this concave lens, it is one type of concave lens. This type of concave lens, see the shape of the concave lens. See, one side, if you can draw a central line, one side is more bulged and another side is small bulging, thicker. One side is more thicker than other side. So maybe this lens and all you are using in laboratory purpose, labs for research or anything. Not mostly they are using, some reason they are using, what is that? This concave lens. Okay. Next one, biconvex lens. Okay. This is nothing but biconvex lens. So this is the biconvex lens which I show you. Both the side it is bulged. If you draw a central line, both the sides it is uniformly spherical mirror. We can say it is a spherical mirror. Both the sides if you draw a central line. Okay. It is uniformly spherical mirror, we can say. Okay. So where these lenses are using? We are using in microscope, telescope or projectors. So in many purpose we are using. Okay. So this is a main purpose. Large number of lenses they are using for different purpose. Mostly these lenses are using. Okay. Another one, it is nothing but plano convex lens. Okay. It is nothing but plano convex lens. So plano convex lens means it is semicircle, we can say. It is a semicircle, half spherical. It is not uniformly spherical. Okay. So see the central line, only one side it is spherical. This lens is also used in laboratory purpose. For research purpose they are using in laboratories. Okay. Another one, most important, positive meniscus. Okay. It is nothing but positive meniscus, this lens is. So where are this positive meniscus, the lens they are using? So they are using for most probably for contact lens. Okay. For eyesight, whether it may be long sight or short sight. So for many purpose, for contact lens they are using, what is this? This positive meniscus. Okay. So this positive meniscus, it is a convex lens, positive meniscus. So where it is used? It is used for, that is hypermetropia. This is used for hypermetropia. Okay. Then, so it is called, what is that? Converging lens. It is called a converging lens. Then another one we will see diverging lens. It is nothing but diverging lens. Okay. So what is that diverging lens? So say it is a 4 types of mirrors, different types of mirrors. Then this is a simple concave mirror. In this we can draw an optical axis. It is a pole center. When the light rays or the parallel beam of rays when falls on the mirror, it may be deviate. Okay, it may be deviate. Or otherwise we can say it is a divert. So it is nothing but diverging lens. Okay, it is nothing but diverging lens. So this concave lens. So the same way, here this concave lens is most probably not used in any purpose. Okay, this is one type of concave lens. Probably it is not using. Okay, then another one, biconcave lens. Okay, what is it? It is nothing but biconcave lens. So this biconcave lens most probably they are using for, what is it? Different purpose in laboratories and for long, what is it? Many purpose we can say. Not only laboratory purpose, for contact purpose or anything, and a binocular like that we are using. Okay, so many purpose they are using this biconcave. So at the center we can draw a center line. So both the sides it is a semi-circle. Okay, so we can say it is a biconcave lens. Then planar convex lens. Okay, this planar convex lens is also used only in the laboratory purpose for research. Okay, then another one, it is a negative meniscus. What is that? It is nothing but negative meniscus. What is that negative meniscus? Already we saw positive meniscus in converging lens. It is negative meniscus in diverging lens. This is also most probably they are using for contact lens. This is also most probably they are using for contact lens. So for contact lens, what is that? This diverging lens. Concave lens is used to rectify the myopia. Concave lens is used to rectify the myopia. Okay. So these are the types of lens. Okay. Diverging lens, converging lens. Okay. There are types of lenses we saw. Okay. Okay, student. Before we saw different types of lenses. Is it? Concave and convex lens and the different types of lens. Now, by using this convex and the concave lens, how the image is forming and the light rays is passing through the lens due to reflection, how the images are forming. Okay, that we are going to see. Okay, so here rule 1, for we are using both the lenses, convex and the concave lens. Okay. So before that you are going to this, you have to know the main important points. Okay, that is, see, this center line is nothing but optical axis. The center line which we have drawn through the lens, that is nothing but optical axis. Here F that denotes focal length. When we pass the light through the lens, it will converge at one point. Right. So that point is nothing but converging point. Converging. Okay. So that is nothing but focal length. Focal point, or otherwise you can say focal length. Okay. F. This 2F is beyond the F. Okay. So this 2F is otherwise called as C, center of curvature. Center of curvature. Okay, this we can say when we draw a curve. Okay, at the center you can see it is nothing but the center of curvature for the convex lens and the concave lens. Okay. Now, what is the first rule says means that say we are using convex lens in front of the object. Okay. When the light rays that pass through the lens without deviation, there is no deviation, it passes through the lens and it comes out, transmit. Okay, it comes out without any deviation. Okay, when the light is passing, coming from the source that hits the lens, okay, when passes through the lens, it will never, what will happen? Deviation, doesn't take deviation, so it comes in a straight line, otherwise you can say. Okay, so the same for convex lens also, sorry, concave lens. Okay, it is for same for the concave lens. So it is a concave lens, it is a convex lens. See, in the convex lens also, it has this optical axis. In that center, we are passing the light source through the lens. If the light source which doesn't deviate, okay, it is coming in a straight line. So this is the rule 1. So due to reflection through the prism lens, it is coming in a straight line. Okay, through without any deviation. So that is nothing but, what is that? Rule 1. Okay. Next for rule 2. Okay. So what is that rule 2 means? Here say a single source, a single ray of light rays which is coming through the convex lens and the concave lens. See the second diagram. Here number of rays. What is that? Here number of rays. Parallel beam. It is parallel to optic axis or principal axis, we can say. Okay. It is the number of rays which is parallel to optic axis and falls on the lens and converge at one point. So for that purpose only we are telling this convex lens is a converging lens. Is it? Concave lens diverging. Okay. See, all the rays are meeting at one point. So that is nothing but converging. So that is the focal length of this parallel beam of rays. Okay. So through the lens. So it is nothing but converging lens. Okay. So all the rays are coming parallel to the optic axis. Okay, the same way. Okay, for concave lens also. See, when the rays are falls on the concave lens, it is diverged. It doesn't converge. Okay, it doesn't meeting in one point. All the rays are diverging in different direction. Okay, but in front of this lens, all the rays are converging. So this point is nothing but, what is it? Focal point of the concave lens. Focal point of the concave lens. Okay. So all the rays are diverging. These rays are parallel to the optic axis. Okay. But after the lens passing through the source are passing through the lens, all the rays are deviating. Okay. So here the deviating rays is nothing but real image. Okay. The same way this focal point, that is a dotted line, that is nothing but virtual image. Okay. The same way all the rays in concave lens falls on the concave lens and meeting at one point are converging. If we keep a screen or white cloth, we can see the image on the screen. Okay, so all the point meeting at one point, we can see the clear image. Okay, the image will be inverted. The image will be inverted. Here it is the diverge. Okay, all the rays are diverging. The same way in opposite side it is converging. So that is nothing but, what is that? Focal point of the concave lens. Okay, so what is the concept means? All the rays are parallel to the optic axis, that is converging, and then in concave lens it is diverging. Okay, so what is that? Rule 3 means, say it is an optic axis in between this lens, center of the lens. Okay, so it is nothing but pole point, center of the lens, that we can say pole point. Here, the rays which is coming through the focal point and pass through the, what is that, lens, it is parallel to the optic axis. It is parallel to the optic axis. Okay, so see here, the rays, light rays from the source or any object, it is coming from the focal point and hits the lens. Okay, the rays that hits the lens and passing through the lens in a parallel to the, what is that, optic axis. It is the opposite to this. Okay, so here what is that, the rays which is coming parallel and converging. Okay, the same way here, the rays which is coming through a focal point, and after that, what is that, it is the rays which is transmitting parallel to the optic axis. The same way, the diverging rays when it hits the optic axis, okay, that optic axis, it is also parallel. It is also parallel. Okay, so the rays which comes and then falls at the concave lens, and the outer, so this is a, what is it, diverging rays. Okay, in different directions the rays after falls on the lens, it is parallel to the optic axis. So this is the third rule. If you know these three rules, it is easy to understand about the optics, that about lens. You can easily study the ray diagram of the convex lens and the concave lens. Okay, so this you must not memorize. You have to understand these three rules. So this is the first rule. What is that? The rays which is coming without deviation in a straight line. Okay. Then second one, what is that? It is the rays which is coming through optic axis parallel to the optic axis. Okay. Then third one, it is the rays which is coming through a focal point and it is parallel to the optic axis. Okay. Thank you.